sklearn, model selection, stratified K-fold. Description: a cross-validation object that returns stratified folds. The folds are made by preserving the percentage of samples for each class. Inputs: n splits number of folds. Must be at least 2. Shuffle: whether to shuffle the data before splitting into batches. Random state controls the shuffling applied to the data before applying the cross-validation. Pass an int for reproducible output across multiple function calls. See glossary. Outputs: train index the indices of the training set. Test index the indices of the testing set. Steps: data is split into folds based on the n splits parameter. The folds are stratified, meaning that the proportion of samples for each class is maintained in each fold. If shuffle is true, the data is shuffled before splitting into folds. The train index and test index arrays are returned for each fold. Metrics: accuracy, the percentage of correctly classified samples. Precision, the proportion of true positives among predicted positives. Recall, the proportion of true positives among actual positives. F1 score, the harmonic mean of precision and recall. Visualization plots. Confusion matrix, a visualization of the true positives, true negatives, false positives, and false negatives. ROC curve, a plot of the true positive rate against the false positive rate. Precision recall curve, a plot of the precision against the recall. Fine-tune parameters. N splits, the number of folds. Increasing n splits will generally lead to more accurate estimates of the model's performance, but will also take longer to run. Shuffle: whether to shuffle the data before splitting. If the data is already shuffled, you can set shuffle to false to save time. Uncertainty methods. Bootstrap resampling: repeat the cross-validation process multiple times with different random samples of the data. This can help to estimate the uncertainty in the model's performance. Bayesian methods: use Bayesian methods to estimate the posterior distribution of the models. Parameters. This can help to quantify the uncertainty in the model's predictions. Challenges and fixes. Challenge 1: imbalanced classes. If the classes in the dataset are imbalanced, then the model may be biased towards the majority class. Sample use case that resulted in challenge 1: a dataset with 90 positive samples and 10 negative samples. Fixes to challenge 1: oversampling the minority class, undersampling the majority class, or using a cost-sensitive learning algorithm. Challenge 2: small sample size. If the sample size is small, then the cross-validation results may be unstable. Sample use case that resulted in challenge 2: a dataset with only 100 samples. Fixes to challenge 2: increase the sample size if possible, or use a different cross-validation method such as leave one out cross-validation.